So now we'll be solving question number 10 from exercise 2 from chapter called Laws of Motion, which is in the phase 1 book. Okay. Now let's see the question. According to question, a body of mass 60 kg is dragged with just enough force to start moving on a rough surface with coefficient of static and the kinetic friction. So static friction is given 0.5 and the kinetic friction is given 0.4. We all know how the friction changes. When it is about the value of friction based upon the net driving force, as we keep increasing the driving force, friction keep increasing. In the beginning, the friction is static, body is not moving till this point, and it reaches till the maximum value, Fs max. So till this point, body will not be moving. And then suddenly, once the external force, net driving force crosses the Fs max, the body starts moving. But the thing is, the moment net driving force crosses the Fs max, friction suddenly drops slightly. And it becomes Fk. This friction is Fk. So Fs max is more than Fk, slightly more than F. So for Fs max, coefficient of friction is given 0.5. And for Fk, coefficient of friction is given 0.4. Now, if I want to move the body, I need to cross the Fs max. So when we are talking about just enough force to start moving, it means the driving force must have been just more than Fs max. So that driving force which is trying to move the body is equals to Fs max. The value of Fs max, again, it is mu times of n. And in this particular case, n will be equals to mg. So let's put the value. So 0.5 multiplied with mg, mass is 60 multiplied with 10. That brings to 300 Newton. So if you want to move this body, the net driving force should cross the Fs max. So minimum value of net driving force should be 300 Newton. Once the body will start moving, the net driving force will not change because it's a constant force. But the friction will change. Now, when the body is moving, when body moves, the friction will be Fkn, which is again mu times of n, but this time coefficient of kinetic friction. That is 0.4 multiplied with mg, and that will get you 240 Newton. Once the body starts moving, the friction becomes 240 Newton. So let me make the F very when the body is moving. So when the body is moving, driving force is CRT. Resistive force is 240, which is kinetic friction. Mg is downward. Normal reaction is upward. These forces are balanced. Along the horizontal, forces are not balanced. So we'll get the acceleration. Let's say the acceleration is A. So along the horizontal, I'll apply the second law. So net force along the horizontal is 300 minus 240. And that is equals to m times of A, which is 60 times of A. So acceleration, we will get as 1 meter per second square. Now in the question, they are telling us to calculate or take the G as 9.8. So if in place of 10, if I take the 9.8, in that case, I'll get the acceleration as 0.98. And that is the A option for you. Okay. So in this question, we have learned that when we want to move the body using the driving force and increasing the driving force, first you have to cross the Fs max. And then only you will be able to move the body. But when you are moving the body, you will see the sudden acceleration, sudden jerk you will see. And that jerk and the sudden acceleration after the motion in this particular case will be 1 meter per second square, or you can say 0.98 meter per second square. And this is with every real scenario. Okay. So this is how it happens when the body will be moving and the sudden jerk will be observed. I think you understood. Okay. Thank you.